Hi Year 12. So this is going through the mechanics stuff that we're asking you to do on adding forces, basically when they're written as vectors. Now, if you remember last week, one of the things that we did was we calculated resultant forces by effectively doing things pulling up, take away things pulling down, and things pulling right, take away things pulling left. Now, the reason that vectors come in so handy in mechanics is that they express that already. We know that if remember I goes that way, and J goes up and down. So if I is positive, it'll be going that way. If it's negative, it'll be going that way. And J, if J is positive, it'll be going up. And if J is negative, it'll be going down. So it tells us which way they are moving, effectively, the forces. So what we need to do to find the resultant is effectively just add them together. Really, really easy. So, example 3, the force is 2i plus 3j, 4i minus 1j, minus 3i plus 2j, and ai plus bj act on an object which is in equilibrium. If it's in equilibrium, it means that it's not moving, which means that the resultant force will be 0i plus 0j. Okay, so all we need to do then is if we add up the ones that we've got 2i plus 3j, we've then got 4i minus j minus 3i plus 2j. And then I'm going to leave those for a second. I'm just going to add these ones up. 2 add 4 is 6. Take away 3 will give me 3i. 3 minus 1 is 2. Add 2 is 4j. And then I need to add on to these ai plus bj so that I will end up with 0i plus 0j because it's in equilibrium. Well, what do I need to add on to 3 to get 0? It means that a must be minus 3. What do we need to add on to 4 to get to 0? It means that j must have a coefficient of minus 4. So that's all you're doing. Okay. Right, example 4. So a lot of the time, they'll say this first question. In this first sentence, sorry. In this question, I represents the unit vector due east. That just means that I goes across that way when it's positive. And j represents the unit vector due north. So when j is positive, it means going up. So it's effectively just saying that's what's going on. Okay. So if you see that, don't panic. It doesn't mean anything. It's just, again, mathematicians writing things out, making ourselves sound a little bit more clever than we are. So a particle begins at rest at the origin. It is acted on by 3 forces. There's my 3 forces there. Find the resultant force in the form pi plus qj. So just find the resultant force by adding all them together. So part A, we're just going to add 2i plus j, 3i minus 2j, and minus i plus 4j, and see what that resultant force is. So 2 add 3 is 5, minus 1 is 4i, and 1 minus 2 is minus 1, add 4 is 3, 3j. So that's my resultant force there. Very, very easy that. Okay, and again, remember, we aren't having to do this force, take away this force, because it's already described to us in positives and negatives. Part B, work out the magnitude and bearing of the resultant force. What this means is, imagine 4i plus 3j. Effectively, if we start there and go 4i, that means going 4 units that way. And then 3j, that means going 3 units that way. What it's asking here is, how effectively the magnitude is, how far away are you? What's that actual distance there? Hopefully you can spot what we're going to be using here. We're going to be using Pythagoras Theory. If I want to figure out that magnitude there, I'm going to do the square root of 4 squared plus 3 squared, okay, which will end up giving me 5. This would be the same sum even if these numbers were negative, by the way. So let's say that was 4i minus 3j. Remember that whenever you square it, it's going to be positive anyway. So you'd still, if you wanted to do it like that, put a minus and put it in brackets if you need to, but it will always be positive answers there. Okay, right, and the trickier one, and the bearing of the resultant force. Well, the bearing, remember, we're starting from there. So there's my north line. The bearing will be that angle there. So that angle will be, you've got a choice basically. You can do it one or two ways. You can either figure out this angle and take it off 90, or you can spot that that will be a Z there. So if I can figure out that angle up there, that'll be the same as that angle that I want. That'll be the bearing. So I'm going to figure out the angle theta, which means that that's opposite and that's adjacent. So theta will equal times the -1 of opposite, which is 4, over adjacent, which is 3. I'm going to put that into my calculator. So I get 53.1 degrees. However, it wants it as a bearing. That isn't a bearing. A bearing has to be 3 digits and no decimal places. So it needs to be, my bearing is 0, 5, 3. Okay? And describe the motion of the particle. Well, the motion of the particle, it's accelerating northeast, isn't it? Okay? If a force is acting on something, remember, it will cause it to accelerate. So it's accelerating. I suppose we can say what bearing it is, can't we? Accelerating at bearing 053, which is roughly northeast, not perfectly northeast, that would need to be 045, but yeah, sort of in the northeast direction. Okay, right, now that you've got the 2 examples there, can you have a go at the exercise on the next page and just do up to question 8, please? Only do one part of each question, don't worry about doing like A, B, C, D, E and F, just do part A for each one.